Good evening, good morning, everyone. Please, can you hear me? Please, can you confirm if you can hear me? Okay, welcome to today's class. We are trying to onboard you for those of us that have not joined the LMS app. So, we want you to know that it is important for you to join this to log into the app because that's one of the things that count for your attendance and your participation in this course. So, hello everyone. Before we dive into today's lesson, let's take a quick moment to talk about your most important tool for this entire journey, our LMS. That stands for Learning Management System. So think of the LMS as your personal command center for this bootcamp. Everything you need lives here. So why do you have to have your LMS? It is where you will join all your live classes, just like this one you are joining. So you are to join from your LMS. And your LMS is also where you access all the materials, the recordings and resources. For those of us who are always asking for the slides that the facilitators are using, the place you'll be able to access all the material is right there on your LMS. And it is how you track your own progress. How do you know how far you've gone? How well are you doing? You can only track that on your LMS to see how far you've gone. And it's also a place to connect with your peers and the instructor. You want to ask questions from your facilitator, you want to or you have some questions you want to ask from any other person. Maybe you are trying to do one of the projects and you need some help, your LMS is a place where you can connect with your peers. So, what is the first thing you need to do? So, as the first time login and your first time login and access step, for those who are just joining, you've not been onboarded to the LMS at all, or you'll be finding it difficult to log into your LMS. The first thing you need to get is log in, go to the portal, you already have the message sent to your email, the link to the portal you need to download. So just go to your Gmail, go to the portal, open your browser and type in the specific domain. That's portal.learnlive.site. You should see the login screen when you type in the domain. So you input your login details. That include your username, the exact username and password that was sent to your initial your welcome email. So enter those to log in to your LMS. And if you have any trouble logging into the LMS, you don't need to panic. All you need is your login details aren't working. So the best way you can fix that is clicking on lost password on the LMS. If you are finding it difficult to log into your LMS, so just click on lost password, then follow the instruction, the prompt that will be sent, and check your email for a link to reset your password. And once you have reset it, you can then log in. So for returning users, you've been using it, you have been onboarded to the LMS, but you are just returning. So you just have to welcome back, log in as usual. Your inputs, that is your email and your password. You can go straight to your course. Make sure you are actively marking any completed session or classes as done. There is a place you have to mark done to keep your progress tracking accurate. So your key tasks on the LMS, what are your key tasks on the LMS? Number one is for you to take attendance, and number two is engage and learn actively. So taking your attendance right after the section ends, like when immediately the session ends, you have to take your attendance. So if you go to your course session for the class, click the mark as done button to record your attendance, and that will be on your LMS. This is how you will officially measure your participation and commitment to the program. So do not forget this step. And second is engage and learn actively. The LMS isn't just for watching video. Go into the discussion forum, join the conversation, share your thoughts, ask questions, and respond to your prayer. Active learning is where real growth happen, and we want to see you engaging. So from this, what is expected for you is to go to your LMS, do the needful, and keep your progress tracking accurate.
Okay, good evening, everyone. Please, can you hear me? Good evening, everyone. Those on link on YouTube, can you hear me? Good evening, everyone. Welcome to today's section. Please let me know. Just type if you can hear me. Um, Let me know if you can hear me. Okay, Fitz, thank you. Um, okay, yeah, okay. I think others too can hear me. Okay, so I believe um, you can all see my screen. I think I can see that a lot of people say they have questions around the LMS. I believe that um, Faith have already answered most of the questions around the LMS. So if you have issues with that, probably you can just go over the recordings again, right? So let's continue. So good evening, everyone. Good morning, good afternoon, from anywhere we are watching or we are listening from. So um, I hope I hope we are enjoying our I hope we are enjoying our data engineering class. I hope it's not hard. So I would love to hear feedback from you before we continue today, because today's topic is a little bit advanced compared to what we did last week. So I would like to hear feedback from us, or maybe let me just hear from you what you learned last week. So I would love to see our comment, whatever we learned last week, can we just drop it on the comment section on YouTube for those people, for those on YouTube? So whatever you learned last week, so let's even see whether people are even following to be sure that we're on the same page. So I would like to hear from you guys. So please, whatever you learned last week, just drop it on the YouTube channel so that let's just see one or two comment, or if you have any questions that you want me to quickly look at before we continue to this session, I will appreciate that. So those on YouTube, please can you just drop your comment, tell us what you have learned last week, so I'm expecting a response from us to be sure. Faith, so that it's not be that it's just only Faith that is here with me. I need to be sure that every other person are also following. So what do we learn last week? I'm expecting response. If not, we will not do class today. Oh. So let's drop our comment. I hope you guys can hear me. I believe everyone, because I'm not seeing any comments on the channel, on the YouTube channel. So please let's drop a comment. If you can hear me, just tell us one or two things that you learned last week. What did you learn? What did you learn last week? Okay, all right. Are they doing? Okay, so are they doing? I can. Yeah, let's hear from you. What did you learn last week? Let's hear from everybody. Also, please let's try to invite our friends that are not on the call as well. Good evening. Frustrated right now. I can't get the right SQL to download on my Mac. I tried using the live SQL, and at some point I was asked to pay. I could not practice. Good evening. Okay. Um, okay. Someone said creating, updating tables. Okay. The person that is having issues downloading SQL. Okay. So please, I will look for. I will send some YouTube materials, right? So that you can watch it on how to download. I think you are using Mac. The person said she's using Mac. So I will try and get some other materials for you to be able to download SQL Server or any um, IDEs that you can use with your Mac. Yeah. Okay, a lot of people are saying creating, updating, SQL function. John is used to combine data from multiple tables. Okay, let's hear from. We talked about a lot of stuff last week, so I need more. Let's get more response from people. Please, I need more response so that we can continue to this class. Irene, okay, yeah, Irene, yeah, you can just follow up. Maybe you can just do a follow up so that I can remember as well. But I will make sure that I remember to send materials on how to download on Mac. Yeah, yeah. So I'll do that. I couldn't practice as well, but Highland joined. Okay. It's difficult to practice. Ask for data you used to teach us severally to no avail. A lot of people say it's difficult to practice. It's not actually difficult. Actually, it's not difficult. So when it comes to data, right? Even if you don't have access to my data, you can you can um, you can make use of any data that you have at your disposal, right? Just get a data at your disposal, go to Kaggle, or you can generate data from ChatGPT yourself as well, right? But all other information that you need, I will pass it across to the studio manager so that you can have it on the you guys can have it on the LMS system as well. Align data type, how to create table, join a multiple table. Yeah, that's fine. So okay, that's fine. As for the data, okay. Yeah, I think I've gotten enough comments. So thank you guys for showing that you guys are learning something. Some people say they learn join. Some people say they learn function. Some people say they learned data type, right? So it's sure that you guys are following. Okay, someone says city. Yeah, interesting. Yeah, common table expression. So that shows that you guys we are together. Yeah, it's one thing is that it might be difficult at the beginning, but one thing is just that please let's put our mind into this thing, right? Let's put yeah, you might have challenges installing your SQL server, installing my SQL, or any ID that plan to use. It might not even be working on your system. Your system might not even have the capacity to achieve that. But I will try to encourage you guys not to stop. Right? Don't stop actually. So I will try as much as possible to put everything in place so that you can also follow up as well. But you can, like I said, try to use the online version if you cannot download it. Yeah, the online version does not might not have the capability to be able to function compared to the one I'm using, because the online version have some limitation. They might want you to pay to have the advanced or the robotics system built inside it. So that might be some limitation. So, but don't let that stop you. We will always have to find a way to come across, able to overcome any challenges or to troubleshoot any issues that we come across. So, if you have challenges, you can always, maybe what I will try to do is that faith for people that have challenges, right? Maybe I don't know whether there's a platform so that if there is a frequent ask questions or issues that they are having, if there's any way they can communicate, or maybe on the LMS system, you guys should also try to use the LMS system to communicate the issues that you're having. So maybe from there we can also assist you in all these issues that you're talking about. So, but thank you very much, everyone that dropped one or two things regarding the learning so far. So, my name is Fadanunsho Ajala, and I think we have done introduction. I've done introduction last week already. So let's move on to what we are here for today. So today we are moving a little bit. We are moving a step forward, right, compared to where we had last week. Um, Okay, someone said that they have a WhatsApp group. Okay, probably I will find some resources and share. Um, I will share with you guys on your WhatsApp resources, on your WhatsApp group as well, or tell the coordinator to do that with you. So today we are going to be looking at another topic. So please let me know what you can see on the screen. I'm not going to see what I'm seeing on my own screen. So I want you guys to tell me or just type in what you can see on my screen. Can you guys type in what you can see on my screen? Good evening, everyone. Yeah. So what can you see on my screen? Please, can you type in what you can see on my screen to be sure that everybody can see my screen? So let's type what you can see on my screen. What can you see on my screen? What can you see on my screen? Data warehousing fundamental. Good, good. All right, all right. So today we're going to be talking about data warehousing fundamental, right? So we are engineers. We want to start talking about concepts, talking about things that you'll be hearing a lot of data engineering talking about. You'll be hearing data warehousing. So what is data warehousing, right? So we're talking about that concept today, data warehousing. So we want to master the concept and architecture of modern data warehouse as well. Yeah, data warehousing fundamental. That's what we'll be talking about this week. Actually, we're talking about data warehousing this week as well. So what is data warehouse? So a data warehouse is a centralized repository that aggregates historical data from multiple sources into a unified system designed for analytical queries and business intelligence. Unlike operational database optimized for transactions, data warehouse prioritize analytical performance through specialized architecture and storage mechanism. Now, so once you start, as you begin your journey in data engineering, right, you'll be hearing concepts like database and you'll be hearing something like data warehousing. Now, you might be confused. In fact, a lot of confusion that, oh, what is a database? What is a data warehouse? Are they the same? Are they not the same? What is the difference between them and all? These are the things that you come across, as you start your journey. Now, data warehouse is not actually totally different from a database. I think it is just understanding the concept that matters now, so that we understand it. Once you understand the concept very well, right? So that whenever you are using the word data warehousing or whenever you are using the word database, you understand the context of what you are using it for, right? So last week I told you guys that database is a what? Who can tell us? I need to understand. Okay, so let me ask a question now. I believe there's a quiz coming up maybe later today. So you guys should be preparing for quiz, and maybe on your LMS system, you will get a quiz for what we did last week as well. So please make sure that you prepare for the quiz and don't fail your quiz as well. So I'm just giving you an hint anyway. So last week I talked about database. So I wanted someone to just type in what is a database in your own word. Don't use ChatGPT. So in your own word, what is a database? So let's see those who are following. What's a database in your own word? Just explain it, in your own word, what you understand by database based on what we did um, last week. So what is a database? Based on your understanding, what's a database? I just want you guys to be following out. So what's a database? Anyone? Um, anyone? Database. Okay, someone said big folder. Okay, database. Okay, I need more context to that. LMS is not working. Okay, database is more like a folder, things related are stored in it. Okay, yeah. So because of time, I will just hold to what this person said. Database is more of like a folder that hold related information inside it, right? That is the definition of a database. And I told you guys last week that you can have a database. For example, now let's say we have a department in an organization. Let's say HR department. Any information that related to HR. So let's say by attrition rates, people that leave the organization, employment rates, maybe you have a table that contains people that are just joining the organization, people that are leaving the organization, maybe HR policy, different things, different files that are related to HR, that is a single database. That database is for HR, right? That database is for HR, right? So now, when you have a collection of database, what did I say? When you have a collection of database, that is what we now call what? A data warehouse. When you have a collection of databases, right? When you have a collection of databases, that is now what we call what? A data warehouse. For example, in organization, in big enterprise, right? You can have finance department, you can have a marketing department, you can have marketing department. Even some companies have customer relation department that are specific for customers, right? Now, these different departments, you have it, they always generate their own data in their company. Now, if you want to create a data warehousing solution, let's say you want to develop a data warehousing solution, you have to create different databases for this entity, right? Now, a collection of those databases is what we now call what? A data warehouse. Because in a data warehouse, we have different entity, different database inside it. So that's what we would now call a data warehouse. And if you look at it, we said what? A centralized repository that aggregate historical data from multiple sources into a unified system designed for analytical queries and business intelligence. And business intelligence, unlike operational database optimized for transaction, data warehouse prioritize analytical performance. Another thing that you should also know about data warehouse is that we use data warehouse for analytical purpose compared to your database system. What did I say? We use data warehouse for what? Analytical purpose. Your data warehouse stores historical record. It doesn't. It's not a real time data that you find in your data warehouse. In most cases, data warehouse can contain data about 10 years, 20 years ago, 5 years. Depending on how your company want to store the data, right? Sometimes 5 years, sometimes 2 years. So that is the information your data warehouse contain compared to your database. So we'll talk about the system also later on. So just like the library analogy, think of a data warehouse as a library. It stores data from different sources. Like I said earlier, you can have different sources like different entity, HR, marketing department, finance department, sales department, right? Organize and catalog so analysts can easily find and read them, right? So in a data warehouse, right, you organize things the way you want it to be seen by your analyst or whoever is querying the data. And that is why we are talking about databases here now, so that if you store it by different database, okay, this is for finance, this is for finance, this is for HR, this is for marketing thing. It is easy for you to easily know, okay, which data is which data, right? So you can easily run your queries and answer business questions on the long run. So both system um okay, just as a library organized both for categories and subject for patron discover data for patron discovery. Data warehouse organize data by business domain and dimension tables for analyst access. Both systems serve the same purpose, making information discovery and usable. So that is that about data warehouse. Now, when we talk about data warehouse, we have different platforms that you can perform your warehouse, right? So we have different platforms that you can perform your warehouse, that you can use your data warehouse. So we have the Amazon Redshift, is a cloud solution, is a cloud base. We have Snowflake, is also a cloud analytical platform as well. We have Google BigQuery, it's also a data warehousing system as well. We also have Microsoft Fabric and Synapse Analytics, right? So this integrates enterprise data platform combining analytical data integration and business intelligence together. So in this our journey, I think you guys will be exposed to Microsoft. Let me say Microsoft Azure, not Fabric now. So we are going to expose you to like show you how to use the Microsoft Azure platform. It's also Microsoft Azure and Microsoft Fabric are almost the same. Like they are almost the same. They are like brothers and sisters anyway. So we'll talk about Microsoft Fabric as one of the data warehousing platform that we're going to expose you to later on in our journey, maybe like week 7 or week 6 or something. So we'll talk about the cloud platform, and you guys will be exposed to that platform and see how things works on those platforms as well. We'll just do a touch on those platforms as well. So yeah, we have a lot of data warehousing platform, right? Amazon Redshift, Snowflake, Google BigQuery, Microsoft Fabric, and Synapse as well. So we'll talk about that. So in case someone asks you that what are the data warehousing platform that we have, these are the one that are the major one at the moment. Okay, so moving on. So let's talk about understanding systems. So we have systems in data. When you hear, in a data warehousing concept or architecture, you will be hearing something around OLTP, whole lab system. So you need to understand what these systems are. So the two fundamental database architecture that we have that serve different purpose in modern data system. So we need to learn how transactional and analytical systems shape our business and operate and extract insights. So in a data warehousing concept, we have what they call the OLTP and we have what they call the OLAPs. So OLTP means online transaction process. So I want someone to help me type the full meaning on the chat for those of us on YouTube. So OLTP means what? Online transaction process. Online transaction process. So help me to type the full meaning there so that others can see it. Online what? Transaction process. That is the full meaning of OLTP. And we also have the OLAP system. So OLAP system means what? Online analytical processing. Online analytical processing. So I want someone else to also let me type the full meaning of OLAPs, which is online analytical processing. So the first one is OLTP, which is online transactional processing, and the other one is OLAP, which is online analytical processing. So we need to understand the differences between the OLTP system and the OLAP system. Actually, these two systems, they actually, if you ask me, they look alike, but they are even the same. But in terms of how you use them is what now made them different, right? Database is database, but how you now use them is now what makes them different. Now, We say one is online transaction process, and we say one is what? Analytical process, right? So let's go further and we'll see what it means. So OLTP, like I said, it power real-time transactions. So OLTP system handle what? OLTP system handle what? It handle days-to-days business operation in real time. They process small, frequent transactions like sales, payment, payment, and customer interaction while maintaining data integrity through normalized schemas. So when we talk about OLTP system, right? So for example, what are the type of OLT system that we have? Like your POS, right? Your HR system, your retail, your bank, right? Your bank. Anytime you made a transaction in a bank, right, or maybe on your app or anywhere, there is a there is a there's a transaction. So that's like, okay, so now to understand what OLTP means now is a transaction. Whenever you send money to someone, you are making what? You are making a transaction. Whenever someone is whenever some when you are debited or credited is a transaction. Now that transaction that you are making, it is being recorded in real time. Hello? The transaction is what? Is recorded what? In real time. There is a database that is storing those information in real time. Immediately you send money to someone, a database is receiving that information. Immediately you whether you receive or you send money to someone, a database is what is storing that information, and that is why we are calling it what? Online transactional processing, because it's a real time information, it's a real time processing. I hope we are understanding the system now. Now in OLTP, information are recorded in bit by bit. Hello, what I say? Information in real time in OLTP system are recorded what? In bit by bit. If I send money to Shola, the system is going to record it. If Shola send money to me, the system is going to record it. Now, if you look at this example that I have on the screen, you'll see you upload the OLTP system showing, you can see Alice, right? Alice, maybe he purchased a laptop, one quantity, it is recorded. If you look at on the 5th of January, Bob purchased a tablet, two quantity, it is recorded. Every information, every transactions is being recorded in an OLTP system. So OLTP system is a granular information. Nothing is statement of account an example. Yeah, exactly. The person that's statement of account, exactly. Statement of account is an example. It can also be an example of OLTP system because your information is granular. Nothing is hidden from you. Nothing is aggregated at this moment. It is being broken down. Do you understand? Exactly. So it is at that level. That is what OLTP says. And OLTP system, your data is also stored in a database. Don't get it wrong. Your data is stored in a database, but how the information is being stored is now what we need to understand here. So now, for the OLTP system. Now for OLAP system, right? So OLAP system enables strategic analysis, right? When it comes to OLAP system is meant for analysis and reporting. What did I say? OLAP system is meant for analysis and reporting. It helps you to summarize and aggregate data for trend analysis and dashboard. Do you understand? So OLAP system focus on more on business intelligence and decision making. That is what the OLAP system focus on. They work with large historical data sets, aggregated, pre-computed for fast computed and analytical queries that support the dashboard and reporting. So in OLAPs, unlike the OLTP system that you have a granular information, the OLAP system does not store information in granular. In the OLAP system, information are what? Are aggregated. And those information are meant for reporting. They are meant for analytical purpose. They are meant for decision making. So, for example, let's say that, okay, in your account statement that you receive in a monthly basis, Those information are for you. When it comes to the executive in a banking system, they don't need those information. Those information are not useful to them. It is those information are useful to you. We understand that as a customer. But when it comes to the executive, to the bank operative system, those information are not needed for them. What they need is probably, okay, they want to know at the end, maybe from the beginning of the month or the beginning of the year, how much does this person have in the account? How much does he have at the end of the month? That is, maybe those are the things that are needed for them. They don't need your breakdown of how you spend your money or anything. Those information are not necessary to them. Do you understand? So whole lab system is an aggregated, is a summarized system. Do you understand? Imagine if a bank is storing the way you transact. For example, now in a day, let's say that you made 20 transactions in a day, and this bank have about, let's say they have about 1 million to 2 million customers. Imagine 2 million customers makes at least 20 transactions in a day. How many data do you think the company, the organization is going to generate in a day? They are going to generate a lot of data. Now, those information, does the organization need it to themselves? No. Even if they need it, right? Even if they want to store the data, they cannot store it in a granular level. They have to aggregate it. Okay, well, what happened when experiencing missing transaction in transfer or payment? Okay, don't worry. What all those ones, the bank they will always figure out missing values or anything whenever it comes to. But I'm not really going to dive into banking data at the moment. Now we need to understand what I want to, so that we not divert our conversation. Our conversation is more of the system used in engineering now. Do you understand? So what I'm trying to say is that OLAP system aggregate information. OLTP is more of granular. OLAP system is more of aggregated information. So instead of, let's say that you have 10 record in OLAPs, in OLTP, by the time you move to OLAP system, you might just have like just 3 records. You will see an example. So just look at this. Okay, I think I showed you this already. If you look at when we are talking about the OLTP system, you see that we have order ID one. You can see all this information. These are OLTP system. The information are granular right here. Now, when we move to the OLAP system, the information has already been aggregated here. This OLTP system transaction want to create some. So you can see here, the only information that maybe this organization need, just give me the total sales for January, give me the total sales for February, give me the total sales for March. Is aggregated at this level. The granular information is not needed in the OLAP system. So it allows you to aggregate information without Faith, I need to be sure if anyone can hear me. Can you hear me, Faith? Sorry, can anyone hear me? Those on YouTube, can you guys hear me? Okay, okay, okay. You can hear me now. Okay. Okay, okay, all right. Thank you, thank you. Sorry, I got a little bit distraction from my devices. Yeah. Okay. So what we are saying is that in whole system, because of the data, you might not understand. Um, you know, you might not really understand some of these. Some of these at the moment because if you are working with a very small data, those you might not understand the impact of aggregating data on the long run because you are not the data you are having is just a very small data. But when you start working with a big data, because for example now company like MTN or company like maybe Access Bank or banks generally, right? The number of data they generate in a day, you yourself, if they tell you how much data they generate, imagine doing transaction 10 times in a day, and the number of customers that they have in a day doing the same transaction, those data will be too much for them to accumulate, right? So instead of them getting those data into their data warehousing system, they don't do that. What they will do is that they will aggregate those information and all. So let's your sound is echoing. Okay. What about now, Faith? Is it fine now? This one. Sorry. Okay. Is it fine now? Is it fine now? Okay. Okay. Thank you. Just to be sure that's fine. Okay. Audio is back now. Okay. Okay. Thank you for this on YouTube as well. So now let's quickly look at the glance of the system. So like I said, in OLTP system, right? You have the information is going to be at a granular level, right? It's going to be at a granular level. But when you are storing it in your whole lab system, whenever you are storing this information in your whole lab system, it's going to be aggregated. So it now depends, right? It depends on your organization or what they want. If you are working with a small company, or your data is not large, right? You can be using your OLTP system to run your analytics and use the data. But the moment you move on to big data, when you talk about big data is not just about the name, it's about the volumes of your data. You understand? It is about the volumes of your data that makes a data big. It is not because 5 naira is smaller than 1,000. No, what makes your data big? Like, okay, when we talk about data, what is the volume? How many rows of data are we talking about? Are we talking about 50 rows, or are we talking about 1 million rows? 1 million rows is even still small data. 2 million rows, to me, I feel like it's still small data, right? If you're talking about big data, you're talking about 500 millions, 1 billion petabyte of data. Some organizations I've worked in an organization that we run a query. Sometimes we run a query. We spend almost 4 hours, 3 hours for that query to run because the data is very large, over 500 million data. Do you understand? So how what's the number of record of your data that makes a data big? And imagine you are running a query, or you are refreshing your system and it's taking 3 hours. You will be frustrated. Imagine you did not even aggregate, and that is even an aggregated data that I'm talking about now. That's an aggregated data. Imagine the data is not even aggregated. That means that it can take 5 days, 3 days for you to run that kind of a warehouse system. So to avoid those, issues of taking times and all, a lot of system has been brought up. You will hear the word of like Apache Spark and all, to make sure that your data runs on time, instead of spending days, instead of spending hours. Within 30 minutes, you can run your queries and all. So but to be able to achieve that, you need to put some fundamental key into it instead of running it on the granular level. Why not aggregate the data? Do you understand? So those are the things that you need to put in place when you are doing your data warehousing, or you are creating a data warehousing project. So to understand the differences now, OLTP system is more of operational. When we say operational, it's at the lower level. When we say the OLAP system is more of the at analytical level. for decision making, right? It is more of aggregated data. Do you understand? So, and when it comes to OLTP system is more of normalized structured. It is normalized. When we talk about the OLAP system most of the time is always denormalized. It's not structured. We'll talk about that later on. It's not structured. We have a lot of we are very running short of time now. Now, that is the OLAP system. I believe you guys understand the difference between the OLTP system and the OLAP system. Now let's talk about dimensional modeling. What is dimensional modeling in data warehousing? So we have what they call data warehouse organized information into three key components: fact tables, store measurable events. Dimension tables provide context. I don't know, maybe some of you on this call might come from maybe data analysis. Maybe you guys understand Power BI or Tableau or whichever BI platform that you might know. So you might get the word dimensional modeling. This dimensional modeling is not different from the one on Power BI or whichever platform that you know, right? It's almost similar. We have what they call the fact table and we have what they call the dimension tables. So fact tables contains information like more of measurable events. What is more important? KPIs. When we talk about KPIs, when we talk about measurable events like sales amount, quantity, you have it in your fact table. And when we talk about dimension table have what? They are descriptive context. They give context to your organization. Maybe your organization want to see customers that are performing customer, right? In the banking system, they use that a lot. They want to know performing customer, which customers give us more when it comes to, I think in the banking system, what they use is more of loans, right? They want customer that can, when you get more loans in the banking system, because you are going to pay interest on it, you are going to be like their top customer. And when you borrow money, when you loan money from bank and you return it on time, they make you more of like they are more of like their loyal customers. And you see that's why you see that most of the banking system, they will, even some banks, I think my bank self, even they will reach out to me and say I should come and borrow money or something. I don't know, maybe they do that for you as well. But that's just the system there. So they might want to know, customers loyalty. They might want to know product, which product are we selling the most? Is it the venture? Is it I'm talking about banking system now. So they have different products in the banking system too that they use. They generate money from. Is it loan? Some loan is also a form of product in the bank. We have loan. They have I think the venture. They have draft. They have overdrafts. Different products in that system that they use. You understand? So then we also have surrogate key. Surrogate key is just like an artificial ID that you get. Maybe you can get that one from your system as well. So we'll talk about this dimensional modeling. So database normalization. So normalization is the process of organizing tables and column in a relational data in a relational database to reduce redundancy and preserve data integrity. It is commonly used to what? To eliminate redundant data, minimize errors and anomalies, simplify queries, right? So when it comes to the database system, actually, the OLTP system is more of normalized data. But when you're working with the OLAP system, you might sometimes most OLAP system are always denormalized. But I think over time, based on what me I've worked with, based on my past experience, majority of my data warehousing system is always normalized. And when we talk about normalized, what am I talking about? I'm saying that we must have dimension tables and we must have what fact tables. Your dimension tables contain unique identifier of your descriptive record, while your fact tables contains the attributes of your measurable data like your quantity, sales amount, and so on and so forth. KPIs that are more important to the organizations. That is what a normalized system is. So when you're talking about database, right, normalization is something that should be key to your heart. You must put it in place because it helps you to eliminate a lot of noises around your data, right? It makes you to eliminate a lot of noises. It even minimize errors for you as well. It minimizes errors for you as well. So that is that. So when we talk about normalization, so please, some of these terminologies that I'm using, you might have to read more about them, like database normalization, denormalization. You might have to try to do more information about them. So we have what they call the data normalization. Now we have what they call the first norm form. We have what they call the second norm form. We have what they call the third norm form. We have what they call the different type of normalization. So I want us to type the different type of normalization that I mentioned. We have the one NF, which is one norm form, the second norm form, and the third norm form. So let's type in those type of normalization that I mentioned: one norm form, second norm form, and third norm form. So let's type it on the chart. Let's type it, the type of database normalization. So when we talk about one norm form, what does it mean? What does it mean? What does one norm form means? So one norm form says that you must ensure each columns contain only one value and each row is unique. In a simple terms, every cell should have a single value, not a list. Each record row should be unique and identifiable by a primary key. That is what one norm form means. One norm form says that each record should be unique. Please, I want to be sure that we can still hear me. Can those on YouTube hear me? Because I can't see anybody typing anything. So I just want to be sure that. Faith, are you still there? Can you hear me? Just need to be sure we are all good. Just to be sure everywhere is good. First not form. Okay. Um Faith, are you still there? Okay, I can hear you. Okay, people on, okay, they say you can hear me. All right, you guys should, help my life. Always comment when I ask questions. It's just a way to know that we are all together. Okay, thank you very much, Faith, for that. So, all right, all right, all right. So we're talking about one norm form, normalization, because these are concepts that you need to understand when you start working as a data engineer. So you need to understand normalization. Normalization is a way of what? Reducing noises, eliminating errors. And when we talk about normalization, we're talking about creating a fat and dimension, right? You want to create what? Fat and dimension. So first normal form says what? Each record must be unique. Each row must be unique. For example, now let's look at this table. Order ID. We have order ID 1001. Now we have product, laptop, tablet. Now what no one norm form is saying is that no, this should not be like this. Laptop is different from tablet. Let each record or each product be on their own. Hmm? Let Faith be on her own. Let Folorunso be on her own. Don't join them together. They are not together. Do you understand? Unless they married. Anyway, which I think is not. So let them be together. I'm sorry, don't let's separate them. Each rose must be what? Must be different on their own. Do you understand? So that is so that is that. So you can see after normalizing it, right? So we have laptop on a separate row, we have tablet on a separate. Each cell has one atomic value. So that is what one norm form is saying. Do you understand? So when you are creating your database, you need to consider one norm form as the first thing. We also have the second norm form. So what is second norm form? Second norm form says what? Remove partial dependency. Second norm form says we should what? We should remove what? Partial dependency. Eliminate partial dependency, meaning that every non-key column should depend on the whole primary key, not part of it. In simple terms, if your table has a composite key, more than one column has a key, non-key data must depend on the entire key. I know that some people will say that what is all this grammar like this now? It is when you start working with the data that's when you understand some of this grammar that you're talking about. Now let's look at the tables on our right. What they are trying to say in the second norm form is that if you look at this table, we have order ID, product ID, price, customer, and customer city. Now, customer Alice is most likely depending on 101. Now, if you look at this customer city is depending on what? It's depending on Alice. City on its own supposed to be, because city is like a location. What they are trying to say is that city should not depend on Alice. City should not what? The city name should not depend on, because sorry, let me get the definition again. Partial dependency, meaning that every non-key column should depend on the whole primary key, not part of it. In term, if your table has a composite key more than one column key, non-key data must depend on the entire key. Okay, so yeah, I'm still right. The city here should not be depending on the customer here. The city himself should have a primary key of his own. Do you understand? Should have a primary key of his own. So we need to separate this table. We need to normalize it. Now, when we normalize it, first thing we need to do is to first separate the product, the customer, and the other table. So if you look at it, product have his own information, product, tablet, price, because these are product information. Customers will have his own information, Alice, London, Bob, Manchester. They have their separate information. Then other table also have his own information, laptop, Alice. These are the other table. Do you understand? So each table have their own information. So no key, not no the customer city here should not be depending on the customer information here. No, let them just have a separate information for themselves. Do you understand? So let them have a separate information for themselves. So that is what the two NF is saying. So that a non-partial, we should remove partial dependency, right? Let faith stand on her own. Let follow stand on their own. So they should not be resting on each other. Do you get? So that is what is saying. Let's move on. We also have the third norm form. So third norm form says remove transitive dependency. Remove transitive dependency. So when the columns depend on another key, non-key column. So when we talk about key, so maybe I should just explain the key now. So we have what they call key, the primary key, and the foreign key. We'll talk about much of that later on as well. So key is very, very important in data, especially when we're talking about data warehousing. Key is very, very important. So what is a key? A key is like a unique identifier. For example, now, we can have so many faiths, the same name, the same surname, even so they might even be looking alike and they are not twins. Do you understand? Now, how do I differentiate faith A from faith B? How do I differentiate them? The only way I can do that is to have a unique identifier for each of them. That is why you see that when we are in school, they don't call you, your lecturer won't call you by your name. I don't know whether some of you will agree with me, right? Lecturer won't call you by your name. Most of the time, lecturer will call you by your words, by your matric number, isn't it? Or when you go to the bank, the first thing they will ever ask you in a bank is what? Your account number. They will not ask you for your name because many people can be bearing that name. Do you understand? In a system, you can have Faith Adewale or whatever name the Folorunso Ajala. You can have a lot of Folorunso Ajala in a database system. How do they differentiate the two Folorunso? Is using their account key, account number. And that is why key is very, very important in a database system or in a warehouse system. I hope you are following. I hope we are following. So, so in the third norm form, the third norm form says that remove transitive dependency. So the goal here is what? We want to remove transitive dependency when a column depends on another non-key column. In simple terms, every non-key column must depend only on the primary key. Every non-key. So when we say non-key, or when we say a key column, a non-key column is a column that, for example, na customer ID. This ID now is a key column. When you hear product key is a key column. When you hear region key or region ID is a key column, is an identifier. So what they are saying here is that a non-key column should not depend. Every non-key column must depend only on the primary key. For example, now look at this zip code. Now, this zip code here is depending on what? Is depending on customer ID. Now, what they are saying here is that this zip code should not depend on customer ID. Alice can depend on customer ID, but you see zip code here, it shouldn't depend on customer ID. Do you understand? So let customer information be customer. Zip code is more of location. Do you understand? Zip code is more of location. So it's very, very how will I say it? I remember when I was working on a project for, I think is a student then. So the person was creating a data warehousing. That is when I understand fully this normalization very well as well. So I would advise you guys, it might be so confused now. It might be so confused. This is an introduction. So you have to take a step back, go and understand what normalization is. You might feel like, oh, you don't need it at the moment. But when you start working with data, you start working with organization, nobody's going to be explaining all these things to you that, oh, put normalization in your database. Don't put normalization here. Nobody's going to be explaining those things to you. So you need to understand those concepts. And, whenever you are deploying or whenever you are creating solutions, you put them in place. So please, you might not understand them now, but go back after this class. I will also try as much as possible to look for resources that can guide you. I think I have some data engineering books. Maybe I will just share them with you guys as well. So please go back and learn more about normalization. You might not the class, we have a very short time together here. Now let's move on. When we talk about normalization is separating information so that they are not repeated, right? Removing redundancy. What if someone now said that, okay, why are we stressing ourselves? Why can't we just put everything together? Why are we stressing? Can't I just match the tables and what is all this? Now, yes, you can do that. Even in, I told you about data warehouse. I told you about OLAP system. The OLAP system, in most of the OLAP system, they are always what? They are always denormalized. So why is OLAP system denormalized? I even let me hear from someone on the. So why will you want to denormalize your table? Or why do you want to denormalize, or why would the data warehouse be denormalized compared to the whole LTP system? If you have an idea, you can just put it on the comment section. Why would you want to denormalize your table? Now, because of time, actually. So the reason why you want to denormalize your table most of the time is because you want to save your data. Maybe you want to save your storage account. So instead of creating, because when you come to normalization is going to cost you a lot because you have to create multiple tables in normalization. But in normalization, just one single table is sufficient. You will just join everything together, VLOOKUP or whatever, or pivot table, join every information together. Do you understand? In that is denormalization for you. But in normalization system, you have to put you have to put what? You have to put all the information separately in the normalization, in a normalized system. Do you understand? But in a normalized system, like I said earlier, because of sometimes some people might be trying to save resources, save costs. Do you understand? They will just, you cannot spend money on buying resources or buying storage account. Let's just join all the table together. When we need the information, we'll pick the information that we need. Do you understand? So, but most of the time it is not efficient. What did I say? It is not always efficient in most cases. It's not always efficient. Merging table creates redundancy and often requires significant more memories and processing power. Even I even say that maybe for storage and cost effectiveness, right? Sometimes denormalizing a table itself can even cost you more. Actually, the fact that you are trying to even save, the fact that you don't want to normalize, right? You don't want to normalize, maybe because you feel like, you create more tables and all. I think even a normalized system is more, it doesn't cost you much, say, because the table will run faster when you normalize, yes, when you normalize, your table will run faster compared to when you denormalize. Because when you denormalize, you just have so many information there, and it can take a longer period of time for the query to run. Yes, so that's why um it's always advised to normalize your table. So let's quickly go on. So we have the fact and dimension. I think I mentioned that earlier on. A fact table is what? It contains information that are more important to the business. It contains information that are what? That are more important to the business. It contains aggregated information. It contains, most of the time, it contains numerical value, like your sales record, your financial record, quantity sold. It contains information that are more interested to your business, to your executive, right? That is what the fact tables, and fact tables contains foreign key. What did I say? Fact table contains what? It contains foreign key. That's where you will see your customer key, your customer key, your product key, your store key. It contains what? Foreign key, foreign information inside it, right? That's your fact table. Then your dimension table contains what? It contains your primary key. It contains, they are more of unique identifier. Like I said earlier, primary keys are what? They are unique identifiers. They make your tables to be unique, right? They make your table to be unique. So I would advise you guys, please, let's try to read more on this concept, on these primary keys, foreign keys as well. So normalization versus denormalization trade-off, right? Normalization, most of the time, it's mostly used in OLTP system. So separate data to eliminate redundancy, and reduce storage but require joins during queries and all. Denormalization is mostly OLAP's focus. Combine related data into single table for query speed, use more storage but eliminate expensive join. Example, customer name and name and country in the same rows, right? Then strategic choices. Choice based on workload. Normalize for transaction system where write dominates. Denormalize for transaction system where read dominates. So we have what they write and read. Do you understand? So whenever you are writing, um, it is always advisable that you use normalization, right? Then whenever you are not writing, maybe you are just reading. Reading means that you are just querying the database, that you should use that denormalize dominate that system. But if you ask me, in any system you are building, depending on your use cases as well, a normalized is always better. Normalized system is always better, because it gives clarity. It reduces noises and all. We also have what they call the star schema. These are data modeling concepts. We have what they call the star schema and the snowflake schema. So we have what they call the star schema architecture. So star schema means what? Is a kind of schema that all your dimension tables, right? All your dimension tables are connected to your fact tables. What did I say? All your dimension tables are what? They are connected to what? To your fact tables. A star schema is the simplest and most common type of data model, characterized by what? A single fact table surrounded by what? Related dimension tables. So you can see your fact table here is the one in the center. You have dimensions around it. Customer information, product information, territory information, calendar information, all these are dimensions. So all your dimensions are connected directly to the facts, to the middle table here. This is what they call a star schema. A star schema is what? A star schema is what? All the dimensions are what? Are connected directly to the fact table. Now, we also have another one called what? The snowflake schema. So a snowflake schema or snowflake dimension is what? When you have a dimension connecting to another dimension before it connects to the fact table. So that is what they call what? A snowflake schema. So a snowflake schema is what? Is an extension of a star schema. What did I say? A snowflake schema is what? Is an extension of what? Of a star schema. So in a snowflake schema, there is what? There is a relationship between two dimensions. Do you understand? there's a relationship between what? Between two dimensions before it gets into the fact table. So that is a snowflake. A snowflake schema is what? Is an extension of a star schema. So you need to understand the two concepts together. So let me see those that are following. So if you are following, can you just tell me what is a star schema and what is a dimension? What is a snowflake schema? So just type in what is a star schema. So let's see those that are following. Let's see what is a star schema and what is a snowflake schema. What is a star schema and what is a snowflake schema? So let's hear from you. So let's quickly do a quick exercise. What is a star schema and what is a snowflake schema? And also, what is a fact table and what is a dimension table? So let's answer those questions. Let's see. Let's see those that are following. So two questions now. What is the difference between snowflake schema and a star schema? And also, what is the difference between dimension and fact table? Maybe I should ask also, what is the difference between normalization and denormalization as well? So someone says Snowflake is this person want to use quick. You want to do quick win. Snowflake is a dimension of star schema. Okay, me trying to assimilate this concept. Yeah. Understanding the concept is very very key. It's very very key. So let's try to understand the concept because now you know that everything that I've been talking about is concept. So I will still do demo for you. I will use the remaining few minutes to do demo so that you can see how this thing actually works in the system as well. So I need more response. Let's get more response. I need more response from us. Snowflake schema and star schema. What is the difference? What is the difference between primary and foreign key? What is the difference between normalization and denormalization? And what is the difference between um, what is the difference between a lot of concepts that I've mentioned today actually. So let me get response from us. Let me get response. Please, are you guys following? Let's drop our comment to be sure that we are following. Please, let's drop our comments. It's only one person that have dropped. Star schema have their dimension directly related to the fact. Yeah, that's true. Daniel Solomon, yeah, I like that your response. Um, the the normalization is fast. Why normalization is faster? Yes, you are right. Yeah, normalization is faster actually because when you normalize your table, it makes your whenever you are querying your database, it's more faster. But normalization, everything will just be joined together. It might take longer hour because normalization will have combined multiple columns. Sometimes in a normalization table, in a denormalized table rather, you might have about more than 100 columns. But in a normalized table, maybe just 5 columns, 6 to 8 or 10 columns. It faster compared to when you join many tables, many columns together. So yeah, you are right. Fact tables contain transaction quantity and okay, yeah, you are good, you are right. Lizzie. Yeah, Lizzie, I think I always see Lizzie, saying something on the call. Yeah, well done. Yeah, fact tables contains transaction quantity and yeah. What about dimension tables? So nobody talk about dimension tables. So let's talk about dimension tables, guys. So why Snowflake schema, extension of the star schema, normalization of separate data to eliminate redundancy. Okay, yeah, I like that. Adekola Hiren, Adekola, yeah. Okay, you are right. Normalization separate data to eliminate redundancy. Yeah, normalization data into single for query speed. Okay. Yeah. Okay. All right. Okay. Okay. So it's fine. It's fine. Let's keep our response coming. It shows that we are learning something. So the purpose of asking the question is just to be sure that we are learning something. Star schema, the simplest and most common type of data model. Snowflake schema, an extension of star schema. Okay, yeah, you are right. So let's keep the response coming. Right now, let's continue. So let's talk about the key takeaway. So the key takeaway here is that the different type of design. We have the OLTP system, we have the OLAP system. OLTP system means that there is no aggregation here. You the way the data is coming, you are storing it, right? You are not there's no the data is coming at operational level, no aggregation, no summary here. That is OLTP system. And it is, for example, now if you go to a POS system, you do your transaction, immediately you transact, the system is already storing the data in a system already for you. But when it comes to OLAP system is aggregated. It is for analytical purpose, right? You want to see trend. Okay, how our customer doing? How our business doing year on year, week on week, right? So you want OLAP system is more for analytical purpose, is for decision making. OLTP system is not for decision making. Nobody is making decision instantly with the data. Do you understand? You're not making instant. The only thing is just that maybe if you have a field record, they can use that transaction to track your information. But when it comes to decision making, they don't use OLTP system for that. OLAP system is what they use for decision making, trend and all. Then we also have schemas. What are schemas? Normalize and denormalize. We have the where we talk about snowflake, where we talk about redundancies and non-redundancy, right? In a normalized database, noises are reduced, errors are eliminated, data redundancy, repeating data are removed in normalization, right? In most cases, like I said, in most cases, some data warehouse, I think like Snowflake, BigQuery, I'm not sure that they have these. They used to, because I know for Synapse, for most people that use data warehouse around, or it depends on whoever is creating the architecture. So I don't want to say there's one rule to anything. Anybody can decide on how they want to build their own data warehouse. There is no rule of thumb to that. I cannot say, oh, you have to build your data warehousing in this way. It just depends on your use case and what your organization can afford. Do you understand? So that's that. But normalization is very, very important whenever you're talking about data warehousing concept. We talk about dimensional modeling as well, fact table and dimension. We talk about foreign key, primary key, and also we talk about snowflake schemas and star schema, types of which are the major two types of modeling, right? So now let's go into the demo section. I think this is what everybody wants to say. Okay, all this story that you have been talking about. Let's even see how it works. Let's see, the fact tables and the dimension tables, right? The foreign key and the primary key. Let's see them in action. When we talk about the snowflake schema, let's even see the snowflake schema. Let's see the star schema, right? So like I told you, the majority of the things that we're going to be doing is more, you know, it's not just about theory, but you need the theory to understand the concept. Because if you understand concepts, when you are now doing the work as well, you understand them better. So let's go into the demo. So let's quickly create. So what we're going to be creating now is that we're going to be creating a snowflake schema and a star schema. Then we are going to incorporate we're going to incorporate our foreign key, dimension key, and all. So we're going to incorporate it into the system that we want to go. So I'll go to my SQL server. So if you can see my studio, for those on YouTube, if you can see my studio, just type SSMS on YouTube. If you can see my studio, just type SSMS for those on YouTube to be sure we are together. Type SSMS if you can see my studio. Type SSMS if you can see my studio. Just type SSMS. Type SSMS if you can see that. Okay, thank you very much, Faith. So Faith can see it. Okay. All right. Okay, I think I'm getting response on YouTube as well. SSMS. All right. All right. Okay. All right. Thank you very much, everyone. It's just we are following. So now we are in the studio already. Like I told you guys earlier, um, when it comes to OLTP system, you can use your SQL server to do your OLTP system. When it comes to data warehousing, you can still make use of your SQL server as well. Now, one thing you should know is that, okay, how is the data being stored? That is what matters. So that is why I have to first explain the concept to you, so that you will not feel like, oh, I have to do data OLTP on SQL Server. I have to go and do OLAPs on one another places. No, you can still make use of your this same system. But when it comes to data warehousing, it is mostly done on the cloud. Yeah, because the cloud environment have more storage, right? It have more space compared to the on-premises environment. Do you understand? So most of the time, the cloud environment, like I mentioned different um, data. So let me even ask you, how many data warehousing system did I mention? Like different type of this data warehousing system that I mentioned. If you remember, just type the data warehousing platform, the cloud platform that I mentioned earlier in this class. So you can just type in those platform. So let's see those that are following. I mentioned about, I think about 5 platforms. Yeah. Amazon, Google. Okay, I think about 4 or 5 platforms. So if you remember those platforms that I mentioned, the cloud platform that I mentioned that you can do your data warehousing, just type those platforms on the chat. Yeah, so that other people that are, that just that did not that did not hear when I said that, they can also catch up with that. So so it is always advisable that you do your data warehousing on the cloud. Yeah, it's because of, yeah, Amazon, BigQuery, Redshift. Yeah, you are right. So yeah, and I also mentioned Snowflake. Yeah, Snowflake. So Snowflake here is not the same thing as Snowflake schema. So that you don't mix them up. Yeah, we have Snowflake as a data warehouse. We also have Snowflake as a what? As a data modeling as well. Yeah, Amazon Redshift. Yeah, then we also have um Synapse Analytics or Microsoft Fabric data warehouse as well. Yeah, so thank you guys for following. It shows that you guys are following. I'm really glad. I'm really glad. Yeah, Microsoft Fabric or Synapse Analytics. Synapse Analytics. Yeah. So yeah, well done, guys. So now let's quickly build a simple, um, you know, Snowflake star schema. Let's just quickly build a simple one like that. So I'm going to be using a script actually. So I'll be using a script to do that. Um, So I'll be using a script to do that, but I will be explaining the script as well. I will explain the scripts. So the first thing I want to do is to create a database. So we want to create a database. So we want to create a database, or should I call the database the incubator? Hmm. Okay, don't worry. Let's continue like this. So we want to create a database. So we want to create a database called what? Sales data warehouse. That's the name of the database, right? Create a database called what? Sales data warehouse. Please provide us with the scripts. Yeah, I can always send anything that you guys want. How to get it is, I think that's the only thing. I can send the script. I will send this particular script. I can send it even right now as well. So don't worry, I'll send the script to you. The script is something that I can always share the script. So there's no problem that. So I will share it. Straight. I don't okay, maybe not you. Maybe I will reach out to Kenny to send the script to her or to whoever the person is. So yeah, I will share the script with you guys. So create a database, sales data warehouse. Then we want to tell SQL Server to use this data warehouse. So that's why I'm saying use sales DW. So let's create this database. So I can see command completed successfully. So I've created this database now. So I've created the database. So if I refresh here, let me refresh here. If you go to your database, you will see the sales DW. And if you open it, If you go to tables, you see that there is no tables at the moment because we have not created any tables um, inside this database. There is no information here at the moment. So now let's proceed. So the next thing that we want to do is to start creating our dimension tables. We want to create our, I told you about dimension tables, and I said dimension table is always what? Is always unique. So dimension table is always what? Is always unique. So let's create a dimension table. So the first, we are going to be creating about 4 dimension tables. So now let me explain. So we want to create customer dimension. So we say create table, dim customer, dimension, dim means dimension. Customer key, integer, it should be, every key is an integer. So integer, then should be what? A primary key. This should be our primary key. And this is surrogate key. Surrogate keys means key that are not business oriented. They did not come from the business. This key is generated by the system. So when you hear surrogate keys means that the key is generated by what? By the system. It is not from the business. It is different from customer ID now. Is a business ID, is a business key. Like maybe your matric, for example, now your matric number is a business ID. Your account number is a business ID. But any ID you generated that is not the business that own it, they call it what? Surrogate key. First name, last name, email address, city, and country. Now you will see something around unique, not null, unique, default, and all. What all this means? What it means is that we are trying to enforce data validation or data integrity in our database creation. What did I say? We want to ensure what? Data integrity, data validation. Unique means that we don't want more than one customer ID here because it's a dimension table. I will say a dimension table contains always what? A unique record. Your dimension table must not contain a replicate information at all in a dimension system. It will not contain what? A duplicate record. So we're trying to enforce a data validation or data integrity here. Do you understand? So that's what we're trying to do. So let's execute this. So after we execute it, let's say select all from dim customer. If you select all from dim customer, invalid object name dim customer, why that? It's not saying the table yet. What happened? Let me run it again. Okay, maybe I didn't run it earlier. So let's check it now. So you can see we have the customer key, customer ID, first name, last name, email, city, and country, and we don't have any information there yet, so it's fine. So we are just still, what we are doing is just to create the table. We're just creating the table. So let's create the next table. So the next table is to create our category table. So we want to create our categories table. So for this one as well, we are saying create table, dim category, category key, integer, identity, primary key. So this one as well is also a surrogate key because we are generating this ID from the system. It's not a business, this key is not a business key. Do you understand? It's not a business key. So we are using the system to generate the ID. So let's create it as well. So we have created the dim category. Now the next one, let's create the dimension table. So let's create the dimension table. So the same thing here, we are using some validation rules like check, and we also use what? Reference. You can see foreign key here. Foreign key, because the reason why we are using foreign key here is because we have category key. Category key here is a foreign key here. The initial table that category key belongs to supposed to be the category table. We're not supposed to be saying category key here at all. So, but the moment we say category key here, it become what? It become a foreign key. Hello, it become what? It become what? A foreign key. So that is why we are saying it here. So now let's create this table as well. So let's create this table. So we have created the dimension table as well. So please, if you have any question, you can let me know. If you have any question while creating this system, let me know. So the next one we are going to create is the store table. So the same thing as the store table, right? So we are using the system to generate a store key as well. Then store ID, which is the business unique ID. Then store name, city, and country. So we are generating this, execute. So you can see we have created the store as well. So let's move on to the date dimension. So for the date dimension, we want to create a table called dim date, full date, month name, and year. And we say that the year should be what? Should be greater than or equals to 2000. We are using the check validation to do this. So the year must not be what? Must not be less than. So what it means is that if someone want to input any record into this data, the data must not be less than 2000. It must either be 2000 or greater than 2000. So that is what it means. So let's create this table as well. So we have created the table. Now, let's create our fact table. So let's create our fact table. So now to create the fact table, now if you look at the fact table, you see that the fact table is a bit, we have more elements here compared to the fact table. Like you can see foreign key. So this foreign key, they are referencing the primary, the dimension table. And if you look at all these key here, they are called foreign key because this is not their initial tables, right? You can see the dim date, it has its own table. You can see this is dim date. And if you look at it, the full date column here, the primary key here is the date key here. If you see date key in another table, it's called what? It's called a foreign key. That is what it means. It's called what? It's called what? A foreign key. So you can see dim date key is a foreign key here. The same thing as the customer table is also what? Is also a foreign key. Product key as well is a foreign key here. Store key is also what? It's also a foreign key here as well. So that is how we create this. So this is the fact table now. So now let's create it. Let's create the fact table. So we have created the fact table. So the next thing that we're going to do is to ingest data into all the so let's ingest data. So let's ingest data. So I'm going to ingest the data. So the first data is to insert data into the dim category, right? Dim category. So let's do that. So let's execute. You can see 5 roles affected. So what that means is that we have inserted data into the dim category. The second one is the dim date. So we have inserted another record here. So let's go to the other tables. So let's okay. So let's continue. So we want to create the dim store. So let's create the dim store. So we want to insert, we want to insert record into the dim store. So let's insert record here. So dim date as well. Let's insert record into the dim date. And the last one is so the last one will be the fact table. So let's insert the editor into the fact table. So let's ingest it into this. So this fact table, right? So my plan is to generate about 25,000 data here. So, but we are going to generate it randomly, right? So so everything that we are doing here is within the system. So we are generating the data randomly, right? So what I'm trying to do here is that we want to say insert data into, if you look at our sales data, where is our fat sales? I think select all from fat sales. If you look at it, we don't have any data here yet, but we want to generate a data that is going to be about 25,000 data. It's just a random data. It's not like we are solving any real business now. I'm just trying to show you how to create, how to generate the data in case, a lot of people will be asking for data, but you can actually generate this data yourself as well. So, but let's see how this works. So now I want to say insert into fact sales, date key, customer key. These are the column name. Then we say we want to randomly, pick the date key, customer key, product key, store key. That's what we want to do. We want to randomly pick the data, right? So random quantity. So the quantity that we want to give, we have a column called quantity. This quantity. So we want to randomly pick quantity between 1 and 5, right? So the highest quantity should be 5, the lowest should be 1. That's what we're trying to do here. Then we said from numbers, we are using a CTE. If you remember, I taught you how to use CTE the last. Is this CTE we are using? Yeah, we are using CTE here. Is this CTE? I think so. Wait, let me check. Yeah, I didn't copy it completely. So we are using CTE there. Yes. Okay. So when I want to send the script, I will make sure I send the scripts completely. So I'll make sure I send the scripts completely. So let me remove this one because I'm using a CTE to generate this. So let me delete this, then paste this back. So we are starting from the width. Yeah, the width number has select top 50 rows. So select top 50 rows. Then we use what's it called? We use window function here, row number and all. So we use a window function here to generate the number from the system. You see the system object is something from the SQL Server system. So that's where you see system.object is a we are just trying to generate the number from the it's like an inbuilt functions within the SQL Server itself. So that's what we're trying to do. They want to insert about 25,000 record, random record here. So let's run this because of time. So let's run this. Let's run this. Execute. So you can see it says 0 row affected. Execute. What's happening? Um, Let me run this again. Zero row affected. What happened? Let me check. Okay. Wait. It's supposed to start from here. Okay. I don't know why this query ran. It was successful when I was trying it. I don't know what is wrong with it now. Select top 50. I'm coming. Select top 50, top 5. Okay, so let me change this one to top one here. See. Let me change this one to top one here. Okay, so let's see. Okay, so zero row affected. I don't know why this code is not generating what I want. And it was successful yesterday now. Let me see. Let me see. Truncate table file sales. Completed. Okay, let me see. I don't know why. Okay, I think this is not working. I don't know why it's not working. I don't know why it's not working. Let me see if to insert 25 to fat sales. Dates, blah, blah. It's actually worked. It worked before I started the class. So I don't know what is. That's sometimes when you are running code at times, this is not like I'm not surprised. It has happened several times. So, but just so that we don't waste much of our time here, right? So the idea is to auto generate a data here. Is to auto generate a random data. I expected this to work. If it doesn't work, probably tomorrow, before we continue our class tomorrow, I will show you how. I will try and test it again and see how that works. But the idea is to generate it. If you look at every other data that we have done, so if you look at the select from all from the if you look at all the other ones that we have done, the data is, is there already. So you can see the data is there already. So I will try and regenerate the code, the fact table code again. I don't know what is wrong, but I will try and work on that again. Or let me see. Didn't I copy the entire code? I copied the entire code now. I copied the entire code. I don't know what is wrong. I copied the entire code. So, but let me run it again. Let's see. Okay. Let me see. Okay, it's not working. The code is not working. So I will maybe tomorrow when we have our class tomorrow, I'll first look at this and see what the issue is, because I don't want to be troubleshooting. If I try to be troubleshooting now, we might spend much time here. So, and I don't want to do that. So at the end of the day, once we are able to create your fact table, so we need to create. So you cannot go and create your database, but this one we might not be able to successfully create it because of we couldn't create the fact table. So probably I will just show you, but tomorrow, most likely tomorrow, I will show you tomorrow before we dive into tomorrow's section. Why is this thing not breaking? I'm coming now. So sales data database. So if you click on new database diagram, so this is what is going to give you. Um, this is going what is going to give you your. So this is what is going to give you your. You can see when we talk about snowflake schema. We talk about schema. So we talk about schema, right? So who can tell me what type of schema is this? What type of schema is this? Who can tell me what type of schema is this? What type of schema is this? Based on what I explained earlier, what type of schema is this? Looking at this schema now, what type of schema is it? What type of schema is this? What type of schema is this? What type of schema is this? Are you guys still following? Are you guys still with me? Are you guys still with me? What type of schema is this? Faith, can you hear me? Let me be sure you can hear me. Faith, can you hear me? Okay, Faith can hear me. All right. Okay, so let's hear from our audience on YouTube. So, what type of schema is this? I mentioned to you earlier when we are creating our when I was explaining the concept. I told you that we have different two major type of schema, and you can tell me what type of schema do we create now? What type of schema do we create? We are able to create our schema, but the fact table does not have data. So tomorrow, I will I will put in the data there. I will share the complete script that is working. So I will share the complete script that is working. So I will test it before joining the class tomorrow again, so we can see how to achieve that. So we'll run the table query tomorrow. So who can tell me what type of schema is this? What type of schema? Based on what I explained, what type of schema is this? Anyone? What type of schema is this? Okay, someone says star schema. Okay, interesting. Any other person? What type of schema is this? And if you are putting star schema, tell us why is it a star schema. Tell us the reason why you choose a star schema. Why is it a star schema? Someone says snowflake. If it's a snowflake schema, tell us why is it a snowflake schema. Explain. Explain to us. Don't just type star schema or snow. Tell us why it's a snowflake schema. If you say it's a snowflake, tell us why it is a snowflake. If you say it's a star schema, tell us why it is a star schema. I need more response. So let's respond, please. Yeah, I will send the scripts. I will send the scripts. You can run the script on your once you have SSMS, you can run the script on SSMS. So I will send the script to you. I just want to once I edit the script and the script is working perfectly, I can send the script to you. So what type of schema is this? Just two people. Like just two people. That's that's not good. So we have just few minutes left. So what type of schema is this? I need more responses from us. What type of schema do we create? What type of schema is this? What type of schema? And tell us why you mentioned that schema. What type of schema is this? I think a lot of people are concerned about assignments, about attendance. You guys are not. Are you sure you guys are following the class? So, what type of schema is this? Snowflakes, extension from star schema. Okay, some people say star schema. Okay, Adewale says star schema. Adedoyin says snowflake hard extension from star schema. Okay. Okay, interesting. All right. Anyway, can the SQL apps work on phone? SQL app does not work on phone. I've said it. It doesn't work on phone. You have to work it on. If you want to become a data engineer, you can't use your phone. Eh? So because but in next classes, you are going to be doing Python in next classes. So you need to be your hands has to be get you have to get your hands dirty from next class. It's not a play class, so you need to be prepared. So you have to use Python. You have to use your phone, your system. You have to use your laptop. Yes, I'm following. Okay, someone said snowflake. Yeah, people that say snowflake, you are correct. So this is a snowflake schema because all the dimensions are not connecting to the fact table. If you look at the dim category is connecting to products. So it makes it already what? A snowflake schema. So this is no longer a star schema again. So this is a snowflake schema. So for people that say snowflake, yeah, you are right. It's a snowflake schema. And you say snowflake is what? Is an extension of what? Of a star schema. If it will have been a star schema if everything you can see if this one is not there. This is a star schema. If this is not there, you have a star schema already. If this is not there, you have a star schema already. So you have a star schema. So yeah, you are right. Those people that say is a snowflake schema, yeah, is a perfect snowflake schema. So if you have any question, please drop your question. I will I will I will answer your question. We have few minutes left. We have few minutes left. So if you have any questions, please ask your question. What's happening here? Why is he doing self join? Have a self relationship. What happened? Okay, this is funny to me. I've not seen something like this before. Okay, so if you have any question, Faith, I think you also want to do some addressing, So I think you can prepare. So if there's no question from my hand, maybe you can you can continue from I can stop sharing so you can take over. Yeah. So let me stop. If there's no question, if you have any question, you can drop your question. and we have some information from our co-presenter here. Yeah, we have some information from our co-presenter. Okay, so let me.
Hello, everyone. Let's take a quick moment to talk about your most important tool for this entire journey, our LMS that stands for Learning Management System. So think of the LMS as your personal command center for this bootcamp. Everything you need lives here. So why LMS? Your LMS is where you join all your live classes, just like the one you just had now. It is where you will access all the materials, recording, and resources for those asking for the slide, assignments, or any other material. It's also how you track your whole progress and see how far you have come. And it is a place to connect with your peers and the instructor. So, how do you onboard yourself on the LMS? The first thing is to go to the portal. An email has been sent to you, the domain for your LMS link. So open your browser and type in the specific domain that has been sent to your email, and you will see on your screen your login details has been sent to you. That's your username and your password that has been sent to you through your email. So do you have trouble logging in? When you have trouble logging in, you don't need to panic. All you need to do is click on your lost password. Once you click on your lost password and follow the instruction and check your email for a link to reset your password. Once you have reset it, you can log in right. And for those who has been onboarded, just go straight to your course and make sure you are actively marking any completed session or classes as done to keep your progress tracking accurate. Two crucial things you need to remember to do after every class. Number one is for you to take your attendance, mark as done. A button. This is how we officially measure your participation and commitment to the program. So do not forget the step to take your attendance immediately after your class. Engage and learn actively. The LMS isn't just for watching video, just to check your class, go for your assignments or check the slide. Go into the discussion forum, join the conversation, share your thoughts, ask questions and respond to your peers. Active learning is where real growth happen and we want to see you engaging. We want to see you engaging on the LMS.